This video is for educational overview only. Viewers are encouraged to study the topic in detail and continue their academic learning alongside this video. Thanks.
All right, let's get into it. If you're a builder, an engineer, you know that feeling, right? That little jolt of excitement when you get an AI agent to work for the first time. It feels like you've created actual magic. But how do you take that magic trick from a weekend prototype and turn it into a bulletproof system that can run in the real world? Well, that is a whole other adventure, and today we're going to map out that entire journey.
So first things first, what even is an AI agent when we get right down to it? At its core, it's pretty simple. It's a program that can act for you, and it all comes down to this really powerful, elegant loop. First, it understands your goal. Then it decides on the next step. It uses a tool to actually do that step, checks the result, and then it just does it all over again. Understand, decide, use, repeat. This simple cycle, it's the foundation for literally everything we're about to talk about.
And this is where the journey always begins, right? In that first moment of creation. You chain a few things together. You build a simple little agent, a prototype, and suddenly you see something incredible happen. And in that moment, the potential just feels absolutely limitless.
And this quote here, man, it just nails it. The real world is messy, it's multi-step. A simple prototype might do something that sounds easy, like, hey, download my meeting transcript from Google Drive and then attach it to the right Salesforce lead. But when you see that work for the first time, whoa, you realize you're not just automating a click. You're automating an entire complex workflow. That's the promise.
But then comes the tough part. You take that brilliant little prototype, you try to run it in the real world, with real users, messy data, unexpected problems, and it shatters. This, my friends, is the production wall. And let me tell you, it's a moment that every single AI engineer eventually faces, where the rules of the game just completely change.
So let's really break that down. What's the difference? A prototype, it just has to work once on a nice, clean, simple task. But a production system, it has to handle insane complexity. It has to run for days, maybe weeks, and it has to be unbelievably robust. It's kind of like the difference between a go-kart and a freight train. Yep, they both move, but one is built for a whole different level of punishment. Okay, so the first huge hurdle you're going to hit is something we can call the context trap. And this is where the agent's own memory, the very thing that's supposed to make it smart, actually becomes its biggest weakness. Just think about it for a second. Every tool you give the agent, every result it gets back, every piece of its own history, it all eats up tokens. And as Anthropic points out, if an agent has thousands of tools or it's trying to process a huge document, it can literally drown in its own information. This doesn't just lead to crazy high costs and slow performance. Eventually, the model's ability to even remember things starts to degrade. They call this context rot. And that brings us to the second big hurdle, the brittleness trap. This is that sinking feeling you get when you realize your agent's logic is just, well, it's too fragile. It's not ready for the chaos of the real world. Simple, unexpected things will completely break it. The team at Grid Dynamics went through this exact thing. They found themselves spending more time just building custom error handling and managing this super fragile state, which they perfectly described as a baton pass that could be dropped at any moment. Then they were actually adding real business value. Their first attempt became so expensive to maintain, they had to scrap it and start over. So the big question is, how do we smash through that production wall? Well, we have to stop thinking like we're just writing prompts and start thinking like engineers. So let's shift gears now, let's talk solutions, and let's look at the toolkit we need to build a smarter, more resilient agent brain. The very first tool in our new toolkit is a whole new discipline called context engineering. You can think of it as the next evolution of prompt engineering. It's not just about what you ask the model to do. It's about being incredibly smart about what information you give it access to at every single step of the way. And this right here really illustrates that shift in thinking. Prompt engineering is all about crafting that one perfect static set of instructions. Context engineering, that's about being a dynamic manager of this whole universe of possible information, the system instructions, the tools, the chat history, and carefully curating the perfect minimal set of tokens for each and every turn. So this is the absolute key takeaway. An LLM's attention is a finite resource. I love this phrase from Anthropic. It has an attention budget, just like our own working memory. And every single token you add to the context, it spends a piece of that budget. So good engineering is all about spending that budget wisely, only on the stuff that really, really matters.
So how do you actually do that, especially for these big, long-running tasks? Well, Anthropic lays out 3 killer techniques. First, compaction, where you have the agent summarize its own history as it goes. Second, structured note-taking, where it uses an external memory, like a digital scratchpad. And third, sub-agent architectures, where it learns to delegate smaller, focused tasks to other specialized agents.
Okay, so once you've got the tools to manage context, you need a blueprint. You need an architectural pattern to structure your entire system. Because you're not just building one agent anymore, you're deciding how a team of agents is going to work together effectively.
And this slide right here, this is basically the cheat sheet for this whole explainer. Drawing on some really great work from Stack AI, we can basically sort most agent systems into one of 4 main blueprints, all based on how they control the flow of work. Just take a second to look at this table. Okay, now let's walk through what each of these really means. First up, you've got the single agent workflow. This is your classic starting point. It's one brain, one loop, and it handles everything from start to finish. It is absolutely perfect for simpler tasks and, honestly, for just iterating super fast when you're getting started. Most projects should probably begin right here. Next, you can level up to the hierarchy. Now, the easiest way to think about this is like a manager delegating tasks to a team of specialists. You have a main supervisor agent that breaks down a complex goal, and then it assigns all the little subtasks to different worker agents. This is ideal when work can be split up and done in parallel, or when different tasks need different security permissions. Third, we have the sequential pipeline. And yeah, it's exactly what it sounds like. It's an assembly line for AI. The output of Agent A becomes the direct input for Agent B, which then feeds into Agent C, and so on. It's super predictable, which makes it great for known, repeatable processes, things like document processing or running compliance checks. And finally, we have the most complex and maybe the coolest pattern, the decentralized swarm. In this model, there's no central boss. Instead, you have a bunch of peer agents that collaborate, propose ideas, and even challenge each other, all coordinating through some kind of shared memory space. It's definitely the most complex to build, but it's perfect for things like creative exploration or analyzing risks from a bunch of different perspectives. Now for the final mind-bending piece of the puzzle. We've built a robust agent, we've picked the right blueprint for it, but what if that agent could actually learn and improve on its own over time? Let's look at how you can build a system that actually evolves. The core idea here, which is laid out beautifully in the OpenAI Cookbook, is to create a continuous feedback loop. An agent does a task, its work gets evaluated, that feedback is used to improve the agent's core logic or its prompts, and then a new, better version becomes the new baseline. It's a cycle of constant improvement. Let's break that down. Step 1, your baseline agent acts. Step 2, its output gets scored, either by a human expert or, and this is wild, by another LLM acting as an impartial judge. Step 3, that feedback is used to automatically generate and test a bunch of new prompts. And finally, step 4, the winning prompt creates a new, improved agent, and that becomes your new starting point. You're creating a system that gets smarter with every single task it performs. And that brings us to a really profound question, doesn't it? We've got on this journey from a simple loop to these robust architectures. But this final step, this changes everything. Maybe the future of REI engineering isn't just about building agents. Maybe it's about engineering the systems that allow them to learn, to adapt, and to evolve, all on their own.